I'm here to present my submission for this hackathon, which is Open Intelligence Agent, Geopolitical Insights at Your Fingertips. Uh, so what inspired me to pursue this challenge was the inherent challenge associated with global events analysis. So any global event is a complex event which has got many factors associated with it, maybe a particular actor or number of factors, a location, and many other factors, due to which the data set associated with an event becomes really complex. And for a non-data specialist, it's very difficult to traverse through that data set and gather a meaningful insight. So our solution is an open intelligence agent, which gives easy access to geopolitical intelligence, uh, just with a natural language query. And our agentic AI does all the hard work in gathering the data set from the ArangoDB cloud. Uh, so yeah, so the at core, our solution leverages agentic AI with custom tools, basically which query data from ArangoDB cloud using the ArangoDB library, due to which it can even leverage GPU for faster retrieval of data, traversal of graph, and after the data set is retrieved, it provides summary of the event in a user readable format, which is much easy to understand, and also offers an interactive map for exploration where the event took place and how the event transpired. Here is a quick overview of the data set that we are using. Shows you different connections between nodes and documents and collections, etc. And I have also linked this image to the main project submission. So a bit about data set. So we are using GDELT Open Intelligence dataset, which is an open source data set which has information of all the global media, news, events in real time, basically used for sentiment analysis and geopolitical analytics. And here is a very high overview of how our agent works. So at the core, obviously, is our AI agent. User sends their query to our agent, and the agent has got access to a bunch of tools that I have built on my own. Since I'm not using the LangChain framework, so I have to build this equal query tool from scratch. So agent basically converts the user query to an equal query, uh, and tries to retrieve data set from the ArangoDB cloud. Once data set is retrieved, it is passed to the data validation tool. A data validation tool does some basic sense check, like whether the data set is empty or it has got data, whether all the dimensions are correct. If not, the information is sent back to the agent, and agent modifies the query accordingly and gets the fresh set of data, which is validated again. And if everything is good, then the data set is passed to the visualization tool based on the structure of data and the different dimensions available. Our visualization tool plots visuals of the event, geographical visualization basically on of the location where the event took place and in what order it took place. And finally, the agent generates a report which is passed down to the markdown tool, and this tool generates a PDF document which can be downloaded by the user for record keeping. So the tech stack. So as I mentioned earlier, we have used Pydantic AI framework for the agent orchestration due to its flexibility and observability. Talking about observability, we are using Logfire uh, to keep track of the agent workflow. Then we have used Streamlit for a user-friendly interface and some custom tools for executing Python code, data validation, querying the data from ArangoDB Cloud Server, and which is used by NX ArangoDB module. And basic functionality of our agent is basically getting the querying the graph database from ArangoDB, validating the extracted data, generating interactive maps, and generating PDF reports. The challenges that we faced while working on this solution was most critical problem was the agent will often come up with the incorrect filters by misinterpreting the user query, and that would lead to an empty data set or an incorrect data set even. So I designed a validation tool that checks the data set for completeness, and if it has got the correct set of columns, correct features. If the data set is incomplete or any feature is missing, the agent modifies the query and retrieves the data set again. And next is the issue with translating the vague or ambiguous user query into the graph database query. And this was solved due to very rigorous experimentation and modifying the system prompt, which helped in reducing uh, this problem to a great extent. So what we achieved, the most proud achievement was the seamless integration of various tools that we integrated with our agent, uh, be it the visualization tool, the querying tool, or the PDF tool. Then the visualization finally, which brings the data to life, makes the data set very clearly understandable and the user-friendly uh, UI, which presents the data set in really digestible format, and a user can readily interpret everything from the report generated by the agent. So what's next for a solution? So we want to expand this data set. Turns out the current data set is only for the Africa region. It will be great if the data feed is live and it's more expensive, so that it's more useful for an actual use case. Improving the accuracy, reducing hallucination, maybe adding more data sources from different sources like internet to ground the agent a bit, enhancing visualization capability, making it more interactive, more user friendly, and giving more information through our visualization. Adding authentication and maybe collaboration where users can share the result with each other over the app itself, and implementing feedback mechanism that will help in improving the agent vastly. So over to demo now. So over to the next section. So I'm using Pydantic AI as the agent framework, and this is where I track the agent responses. We'll talk about this in a bit. Now we'll move over to the agent interface. So I have wrapped the agent in a Streamlit UI. You can see I have already entered all the required credentials, so we can crack on with the agent demo. So for the first demo, I'll ask the question, say, show me the top 5 conflicts within with the most fatalities. Let's give it a time between the year 2012 to 2015. I'm keeping the time frame narrow so that the processing speed is a bit fast. Don't want my app to be cluttered with too much data. While it's processing, we can see how agent is thinking in the log file window. So if we expand this, you can see the first tool here is the run SQL query. Run AQL query, and the you can see the arguments which was sent by the agent to the tool. Just give it a second, and yeah, there you go. So but this is the query, this is the tool output, which is telling the agent that the query was successfully executed and the file was stored there. And next tool is get column names, which will be later used during the validation phase. And the third tool is the validate data frame. After validation, it returned these metrics, which will be used for analysis and visualization. And next is the Python execution tool, which is, I think, agent is using to generate the visualization. And finally, the write markdown file. This is the content which will be written into a PDF file which the user can download. And let's have a look at the UI. So this is what the agent came up with. So top five conflicts with most fatalities. One of them was on 1st April 2015, then on 2nd of February, December, and so on. And we can visualize these events in a map which was generated by the agent. Let's zoom in. Let's see what are the different conflicts. So yeah, there you go. You can navigate these conflicts on the map as well. And let's inspect the data, and you can download it in CSV format thanks to Streamlit. And yeah, so that's the first demo. For the second demo, okay, let's ask the question. Show me all the conflicts where the American troops were involved, or America was involved. Let's keep it short. And yeah, while the agent is thinking, let's go back to our log file window and see what agent is doing in the backend. Same as earlier, it will go through the run AQL query tool, and you can literally see the flow of the agent, how it's operating, how it's going one tool after the other. That's the output from the AQL query. These were the columns. And then off to the last step. Each query takes approximately a minute, which is not too bad. It can be sped up with a better designed agent flow. Finally, the write markdown to file tool. And now we are waiting for the final response. I think we have a response here. Let's have a look. So yeah, so I think there's some parsing error happened here, which is not due to the agent, but mostly I think due to the Streamlit app, where we cannot see the actual markdown file, but we can see the map on which conflicts USA was involved. If we zoom in, you can see the chronological movements and fatalities, kind of event, battle, strategic development, and so on. And also you can download the dataset from there. So yeah, there you go. This is the Open Intelligence agent for you.